Like it's not like it has nothing to do with like your ability to solve the problem. It's your ability to like really just guide me through these design changes. So if you had done that, if you had like focused a little bit more on being able to make this like plain English and understand help someone understand with this, I think you would have been better. You're designed to do the talking, most of the talking, and you're only there to fill in whatever can't be reflected on with design. So give me a little bit of background about yourself. Where are you in terms of your studying? How far out do you think you're going to be scheduling your phone screen? And that sort of information.
Okay, yeah, sure. So I am currently a sophomore at UNC. That's North Carolina,
Mm-hmm.
for those who don't know. And I'm studying CS, of course. And so over the summer, I did not land an internship. So I basically just studied full time. Um, so that's like maybe around 6 hours a day of actual like sitting down, working on questions. Um, and so I went through all of Grok in the coding interview. And then after that, I went through some of Algo Expert, which is pretty helpful. And then after that, I just did some lead code problems to fill in the gaps. And also, towards the end of the summer, in the start of the school year, I started doing some more mock interviews through Prep.
I see. So you seem to be pretty well prepared. Then where do you think the issue is?
Um, a lot of times, I feel like on Pramp, it's like really hard to like draw things out as I would on a whiteboard, especially like really like nuanced questions that have like it's like weird matrix traversals, like the spiral matrix or like a zigzag pattern. And those for me are like I didn't look too much into them because I didn't think they would be that valuable in terms of like best bang for your buck. So like those questions end up being very manual for me. But also like I'm not saying that I'm perfect at everything else. So that's a weak point, but it's not the only part that I want to work on. If that makes
Got it.
sense.
Yeah. So basically you have trouble doing like the mechanical problems from a design standpoint.
Yeah.
I see. Mm, let me think. So there's a few issues that could be associated with that. How are you with designing for normal problems outside of mechanical problems? Like let's say I threw at you a binary search tree problem. What is you? How confident are you that you could tackle it in a very clean way?
So this actually applies to BSTs as well because when I try to like draw it out on like a shared like code pad, it ends up being really messy with like all the slashes and stuff. But for let's say like easy to like easier mediums, theirs are pretty. I can like do those pretty well if you like.
Hmm. Yeah, I'm not asking about the difficulty of the problem. The difficulty literally doesn't matter to me.
Yeah, sorry.
My what I'm really asking is your approach to the problem. I'm trying to judge how clean your approach is. Whether or not this is just like you not being able to handle mechanical problems, or you not like practicing properly. I'm just trying to get a gauge. Um,
Okay.
so just bear with me for a sec while I think. Do you find mechanical problems more difficult, or the ones that deal with patterns more difficult?
You mean like the grokking patterns?
Correct.
I feel like the grokking patterns I can usually apply and like pretty systematically and find a solution. But like more like super nuanced questions, like there's one question where it was like unique or structurally unique binary trees. That's like very like combinatorics heavy, I feel like. Um, and just other like weird like interview specific questions like um, spiral matrix, zigzag matrix, those things. Yeah.
Okay, so your mechanical skill is lacking then. It's not really the pattern
Mhm.
recognition. I think you're okay, so I'm starting to get a little bit of the picture in. Now give me an estimate of how many hours or lead code problems or whatever metric you want to give me just so I can understand how much practice you have?
Yeah, sure. Okay, so I kept a like a timesheet just to like keep myself um you know like accountable for the summer. And so I counted only the time that I was actually sitting down and like actively working on problems, and only on Grokky and on Algo Expert and Lead Code as well. So this doesn't include like Pramp or like extra OAs, which
Sure.
I count as practice. And I got up to around just above like 150.
Okay. Okay, that's fairly decent. That's like, yeah, at that point you should already start approaching your peak performance. So whatever you've been doing at this point, there's not much left as far as like mechanical skill, like not in a sense of solving mechanical problems, but in the sense of being able to actually do these problems in a sufficient way. So you've already pretty much maxed out on the basics. The big question left is how to clean up your approach and clean up how you do these problems, which is a good spot to be in actually. Okay, so um, I think I understand what the issue is. Let me see if I can pull up a problem for you.
All right.
Alright. Do you have an example of the problem that you last really struggled with?
Yeah, let me look at some.
Yeah, just for my reference, so I know I'm not gonna ask you like the same question.
Yeah, I know I struggled really hard um on, let's see, the structurally unique binary trees. I know I said it before. There was one that was like on leak code, the Pacific Atlantic um flow, if you know what I'm talking about.
No.
No, okay, well it's like a matrix question again with DFS or BFS. Uh, and things like, even like for the patterns, like shifted binary search, I felt was like pretty mechanical, because like binary search is like pretty easy, but like having to deal with the offsets was a little more uh, like hands-on, if you like.
I see. Okay, I think okay. Still trying to look up a good problem to give you. So, given a string S, check if the letters can be rearranged so that two characters that are adjacent to each other are not the same. So, if possible, if this is possible to do, you're going to return any of the possible outputs. If not, then you're going to return just an empty string. So, in the first particular case, you have a. I give you the input string AAB, and I can output ABA because this is just one of many possibilities that you can have. This is actually really the only possibility that you can have where A's don't touch each other. But in the second example, that's not possible. So I output a empty string. Does that make
Mm-hmm.
sense?
Yep.
Cool.
So quick question before we start.
Mm-hmm.
Is this like fully pseudocode, or do you want me to do like very verbose with my syntax?
Whatever you want to do. Treat this like a normal interview.
Okay.
I'm very curious. I'm not interested in your answer. I'm more interested in your approach to the problem because I assume whatever you do here is what you're going to do for the mechanical problem. So do it as you would normally.
Okay. So I just want to like just make sure. So our input, we have a string, and then out is also a string with, let's see, so no adjacent repeats, else the empty string. And I'm just assuming that S is like never going to be empty. It doesn't matter. Okay, it looks good. So like right off the bat, let's see, like initial thoughts. We can count the frequency of each letter. And then store that in like some type of like a min heap, or some type of like data structure where we can choose a letter like one at a time and then like rotate them out so that we can build a new string such that we have a new letter at every, or like a different letter at every index. So we get the frequency of each letter and we can put it into a heap. A heap along with its frequency. And then now we have heap to a new string, and then like rotate it out. Okay. So we have like A, B. Our map would look like A would be 2, B 1. Let's store this in. So it looks like we want like something like a max heap here, just to get rid of all the most frequent characters first, and then fill them in with, say, like a lesser frequency character, like B here. And so our max heap would then look pretty similar to this, or like identical to this. And then we just say like while heap like s append like heap dot pop. Let's see, we'd have to avoid having like a duplicate, so we can just kind of like after we pop it out, we can like not put it back in the heap immediately, but then wait until after we process the next letter, just to ensure we don't get any repeats. Let me keep that here. And then, so like, xheap dot push last. Right, so we're pushing back, so like the last character popped off, back onto the heap, and then we'll keep going until we run out of characters, and then we can have like some check to see if we ever do have an issue of Okay, so if we have like more characters than we like, if we have too many characters like up here with A, the thing is if we pop off A and there's no other letters to put after our last A, so say for this example we had like our new string would be something like A, B, A. So we popped off 2 A's and 1 B. Then we just popped off an A. So this is outside of the heap right now. Now the heap is empty because one of our A's is outside of the heap in this last character variable. And so the heap's empty. We break out of this loop. We check if that string has been fully reconstructed. So we just check the length. If it's not equal to the initial length, then we have found like a bad string, basically. Or like we have no result and return the empty string. Does that make sense?
Not really. Can you try rephrasing it?
Sorry, which part?
So, you said that you're dealing with the issue of example number 2, where you have too many of one character. How do you plan to handle this?
Too many. Okay, so yeah, sorry about that. We'd have. I'll bring it down here actually. So we have our input string is AAB.
Okay.
We build our map. We have a frequency of 3. I'll specify this better. frequency map.
Sure.
And then we place, like in Python, we place a tuple
Sure.
of at A, like, actually, yeah, it's a max heap, so it'd be like A comma 3, but here,
Sure, I get the idea.
yeah. And so the way we're going to avoid like repeats, like AA, is that for each letter that we want to place in our new string, we're going to pop it off and store in some variable called last character. Oops. So we can say right here, like last character equals heap.pop. And then we can say, actually, we don't want to put this here right now. We're gonna have a character here, and then once we pop up the character, so it's like here we can pop up A. This will be outside of a heap, so we would store this in some variable called like last char would now be A3 because we just popped it off and put it onto our new string, which I can illustrate here.
Sure.
String equals A. So we
Cool.
popped off A from the heap, and now we store it here as our last character, and we
Okay.
also decrement the frequency. And so this will be outside of a heap. So we can never pop another A off a heap until we pop something else off. And the thing is, if we pop off a B, place a B here, then we'll put our B in the last character variable, or yeah, we'll put it in the last character variable.
Okay.
Oops. Let me pop. Here. We'd have pushed A back on the heap already, so A2, and then we go again.
You might want to mark. So I see that you're decrementing the frequency. You might want to write that down because I don't see any steps.
So after we append, we can just, or even right here, because we get the character in our tuple and the frequency. And to like, after we pop it off, frequency minus equals 1. So we decrement that frequency, and then we store that as our last character. Let's see. So this here would be then like char and frequency. So we pushed, so back here in our new string, after processing the B, we pushed back what was stored in last character, which was our tuple of A, comma 2. And then we pop off A again in our loop. Oops. And we can append it here. So A is now off. And then after doing all that, so I guess we'd have a condition here saying like if we run out of characters, then we're not going to push it back under a heap, right? So that B, since we already put one here, we're out of B's, we're not going to push it back on. And then we set our last character to that A. So now our heap is empty, right? And there's nothing else to pop off if we don't want like a repeat. So we break out of this while loop, and then we check for the length of that new string, see if it's the same as what we had coming in. If it's not, then we weren't successful in our build. If it is, then we just return that string.
Okay, so it seems like you have a bunch of conditions.
Yeah.
So you might want to write those down.
Okay. Yeah, I was I saw your video, the last interview, and you had like really concise pseudocode. So that's what I was trying to go for, but yeah.
It comes with practice.
Okay. So
if I can, I'm going to take a quick 10-second pause, not as the interviewer, but as a person coaching you. Basically, what I'm seeing here is that you are trying to do pseudocode, but it's almost like you're forcing yourself to do it rather than you've naturally practiced to do it. That's just my observation so far.
Yeah, I honestly like Python's is so close to pseudocode. I just always like write my like pseudocode like planing as basically Python.
Yeah. Okay. Keep going. We'll talk more about that later.
Okay.
But I already know what your problem is. So.
Okay. Um. Hmm. So if frequency is like greater than 0, so we still have um. Wow. So yeah, I'm mixing up variables here, aren't I? Like if the last pair uh like dot frequency, let's say, if that frequency of the last character is still greater than 0, we can push that back on our heap. If not, we'll just continue on, save that last character as the one we just popped off, and any other conditions that I need to worry about. And then at the end here, we'll just say like return new string if length equals starting length, else the empty string, like you said.
Okay.
Um, yeah, how does this look? I feel like this would run, and so we're going through each character, we're putting into a max heap, and that takes n log n to build, as max heap operations are in log of n, and we're doing it n times, and then we're just iterating through the heap, n times, which would also take n log n, and up here we are storing this frequency map and also storing the characters in a max heap. So it's O of D, where we say D is like the number of distinct characters.
Okay. Yeah, I think there might be a bug here. Yeah, there might be. Yeah, there's probably a bug here.
On this line?
Just in general.
Okay.
Also, I would encourage you to try and come up with some better test cases, not just the ones I provided.
Okay. So we have one where it shouldn't work. We have a test case where that should work. So I'm just gonna look through and see if I can just find any like jarring bugs just off the bat. Keep recommending here. We're appending that string, that new character that we just popped off. Let's see what character. There's the big like checking if we can push that last character that we just had back onto our heap. So like are there any more occurrences of that character? Then down here, after we push that last character, we can now update it to the character we just popped off. So when are we breaking out of this loop? It's when when we don't have any more characters. Okay. Maybe if we had like A, B, C, C, D. And we store this in a map. Like A, two occurrences, one occurrence to B. We have two occurrences, one occurrence. So we store it in a max heap. So we go like A to or AC. We build our new string like it's like A, and then we have pop up A, decrement its frequency, append A to the string, which would be here. So like if we have a last character and its frequency is greater than 0, then we push it back onto our heap, and we set A to our last character, or we set last character to A. Go back through, pop off, we'll see C this time, and we get a C, decrement down to 1, we'll increment, we'll append it to our new string, last character. So the frequency of A is going to be 1 now, which is still greater than 0, so we'll push it back onto the heap. So A1, we can use the frequency map as our visual. So A right now is 1, and C is out right now. So we go back through, so we pop off like B, right? And then, trying to find like where this would or could go wrong.
Okay. Do you need a hint?
Yes, possibly.
Okay.
Or probably.
Okay, so there's only a handful of cases that you can run into with this loop. So let me first turn my into red just to mark mine. So going into this loop, you have essentially your new string. Your we'll call this your dependence. Is whatever new string is and whatever's in your heap, right? That's going to affect whatever you do in this loop here. Let me turn this. Oh, this is highlight. Shoot, where's the change text color? Yeah, this should be text color. Oh, there we go. Okay, so then you would agree that last character is dependent on new string because this is your string that you're building, so you just really need to get new string last character. So there's no need to have the last character variable. And so the next thing, so now that you've identified that, well then, the situations that you can run into are like if the last character is equal to X for some reason, and then heap, the top element is like X is like 3, or let's just say greater value. Does just give you values just to be so concise. So Y2 da 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 da. That just means that where the top value is equal to last character, right? That's one of the cases that you can possibly run into.
Oh yeah, sure.
Last character equals to X. Just follow me on this, okay?
Okay.
Top value does not equal last character, right? That's your second. That is the second possibility that you can run into.
Mm-hmm.
And then the third possibility is that it goes X equals a heap where the top value and the actually, you know, let's actually do this. There's a sub case here. Is that the top value is equal to the last character, and in this case, that you would agree that you would fail in this one particular example, right? Because your last character is X, and the next frequent one is X. You can't really do anymore, even if you resolve the leg. Well, maybe not. But your goal is to be able to exhaust this entire heap. Because let's say I had Z equals to 2 here. You can still construct a string with this heap remaining, right?
Mhm.
So then what you want to do is just keep pulling elements out of the heap that are not X.
Oh, sorry.
Does this help?
So this last character variable.
Uh-huh.
Oh, I need this outside of the while loop, don't I?
Maybe.
So basically, oh, sorry.
I said maybe, but this is the hint I'm giving you. What if you arrive in this condition? You can still construct a valid situation. You can still construct a valid string, but it would break your case.
So for the whole purpose of the last character variable was to kind of hold like the last used character and hold off on pushing it back into the heap. So in this case, this X would not be here if last character is X.
Okay, I see. So you're permanently removing it from the heap. You're not bringing it back. You're not pushing it back in.
Not until the next iteration, which well, I should keep this out here just to keep it safe.
Okay. I see what you're doing here then.
Yeah.
Okay. So that you permanently remove it from the heap, and then you just get the next element. Okay, then doing that, let me retry that. You have your frequency -1. Into append it to the new string. Okay, then max heap push. And so you push the last character back into the heap. Wait. It just goes against what you just said because let's say I'm in this situation where I have empty string, heap is x3, I pull out x, I append x, and then the last character frequency is greater than 0, so you're going to push it back into the heap.
Sorry, last character in the loop is set here, so it's not set to this x yet until after we push the last character.
I see.
Yeah.
I see what you're doing here. Okay.
Sorry if it wasn't clear.
Yeah. Okay, now I get it. That's my okay. Okay, I think it looks fine so far as a smoke test. Why don't you code it up?
Okay. So again, I'll be doing this with Python. So for this, we just look import the queue, and then so F will say non-adjacent pair. Again, instead of string of S. Okay. So our main thing was we were going to build a frequency map. So we will have freq map equals a dictionary, and then so for I in range length of string, frequency map of that, so S of I. Actually, I'll bring it out to make it more clear. Char equals S at I. The frequency map of that character. Value there, we will set it to frequency map. Get that value, or we'll default to a 0 if there's like no map to it yet, and we will add 1 to it. So we increment if it's already there, or just set it to 0 plus 1 if it's not there. So after we've built up the frequency map, we can now push these into our max heap, which I will just also put up here for now. Heap equals the array. We'll say 4. We want the frequency, or we get the so we're mapping character and then frequency. So character, frequency, and frequency map items. Click through. We'll say max or into the max heap a tuple of the character, and well, actually, we want the frequency. And for our max heap in Python, we want to set the frequency to negative, since heaps are only min heaps in Python. So the negative frequency and the character. So after we built our max heap, let's see what else we need to do. We will say we can start iterating through. So we'll say new string equals empty string, and we will want to check our last character we popped off. Actually, it's been none for now. And then we, like we said, while we have characters left in the max heap. So while max heap is frequency, and the character would be max heap pop, max heap. And we know this frequency is negative. So just for clarity, we could do operations like subtracting negatively, so just doing addition instead of subtraction. But for clarity's sake, we will set frequency to, we'll just negate it, right? So
Sure.
-1 for now.
Okay.
Okay, so we've got the frequency in the character, and we said we want to append that to our new string. S, our new string, dot append, or actually, sorry, plus equals, sorry for the notification. So the character, right? And then we want to decrement its frequency. So frequency 1, and then we want to, so if last character, so if we have a last character in the first iteration, we will not have one. And the last character, this will end up being a tuple, which will be like in the form of character and frequency.
Okay.
So we can say we want the first index of that, which would be the frequency. And if that is still greater than 0, actually, we don't even need this. We can move that check down to when we set the last character. I think it'd be a lot more clear. So if last character, say max heap dot, or sorry, push onto the max heap that last character. So we push it back on to the heap, and then we want to reset our last character. Last character equals, what do we say? So that's the character, and then actually check for the frequency first. So if frequency greater than 0, so we haven't exhausted the that character yet, we'll set last character to a tuple, should be character and frequency -1. Actually, this should be negative because we want to push it back onto the max heap later. So after we set that last character, that's the last line in our loop.
Okay.
And so after that, we break out whether successful or unsuccessful. And then we want to return the new string if length of new string equals the length of s, which was our original string. And this indicates a successful reconstruction, else just the empty string. Okay. And again, this will run. Oh, sorry.
Do you want me to go? No. Let me go to the code really quickly. Okay, car s. Sure. Okay. Okay. Sure. Okay. Think you have a small issue here.
Mm-hmm.
Do you see it?
Oh, wait, no, I don't.
You have frequency -1 and frequency -1 in two places. Oops, sorry.
Oh, yeah,
Yes.
don't I?
Mm-hmm.
Okay. So I guess that would just be negative frequency then. So yeah, small error.
Okay. Okay. Other than that, I think it's okay. Yeah, sure. Go through time space complexity for me.
Yeah. Okay. So for time, we are, let's see, we're going through each of the characters just once, and that'll be O of n read. But then as we're building our max heap, we're placing n characters. Actually, um, it'll be like a constant d, where d is like the number of distinct characters. We'll be doing that d times in log d operations in our max heap build. So it'll be d log d for our complete max heap build. And let's see, we're also in our while loop, we are going through our heap and popping each of them off, which is also going to be in d log d time. Actually, no, because we're going to do it at most n times. So n log d, where d is still the number of distinct characters. So yeah, d log d plus n log d plus O of n, which is asymptotically equivalent to n log d. And then our space complexity, we are storing a frequency map, which will hold same thing, O of d, space where d is the number of distinct characters, same with the max heap. But for our new string, if you want to count that, that'll be O of n, where n is the length of the initial string.
Sorry, could you repeat the overall time space complexity for me? You went through a lot of them. Just what's the overall one?
Sorry, okay. Yeah, time, n log, and if you want to go more specific, n
Just
log
give me
d.
the overall runtime space complexity. Overall,
Sorry.
don't go through it
Okay.
individually. Just give me the overall algorithm.
Okay. Time be n log n, and spaces O of n as well. If we count the string. If not, then O of d.
Your runtime is a little bit off, I think.
Okay.
Let's see. Yeah, I think it's off. Just to go through really quickly. If you want me to just give you the answer, um, it's that this heap you're gonna iterate through n elements, right?
Mhm.
So heap pop is order 1 time, just take it off the top, and then do all these operations. These operations don't really matter for your time. Your heap push is going to be order was it? You're going to do order log n, right? And so you should is like put it in each time. You want this n time. Actually, no, you're right. It is n log n because you're going to be popping things out and then putting it back in and rebalancing it. So you're going to do this operation n times. Okay, that's fine. Yeah, never mind. Okay, it's fine. Sounds good. But I think I already know. But your issue, I'm already very aware of it. We don't need to do another problem for this.
That sounds good.
So the what do you think is holding you back
Um,
in this problem?
well, I'm sorry, what was that?
In this particular problem, you basically went up to 37 minutes. I mean, granted, there was some time when I had to do like some checking as well, but even then, it shouldn't have taken you 37 minutes to get to this point. I think I would have expected you to do it a little bit sooner. What do you think?
Mhm. Very verbose uh, in some places, and also not very verbose in others, which kind of like leads to adding in these random conditions, and that takes up more time, I feel like.
I would argue that your biggest issue is actually you not being able to change your design well, and you not coming up with good test cases. So hang on, let me show you the recording. Okay, so going through my notes, you basically you're pretty good at for like the first 5 minutes. I think it's fine. Um, and then when we hit to 5 minutes, I'm wondering why you start coding. I don't get it. I get that there's like pseudocode, and you told me that you have this habit. Basically, when you because you write in Python, you basically do your pseudocode in Python. But
Mhm.
as you mentioned before, my approach, I almost always use English sentences, so that way I can avoid something like this. I mean, there are times when it's okay to write the code, like for instance, like numerical conditionals. Like if
Mhm.
you need to compare values, I get it, you know. But this is like mostly just like a plain. You can describe this English in a plain English operation. And I think if you're in a position where modifying your design is very difficult, then writing it in code is probably not the greatest idea.
Yeah, it takes a lot more time.
hmm and then here, I think when you get to like around 7 minutes, yeah, I think you focus a little too much on. Let's shoot, I can't remember. Let's see. Yeah, you start to backtrack a little bit and start flubbing your explanation here around here. So
Mhm.
it's like you start looking at this and it's like, oh wait, you consider, yeah, then you consider like the second example that I gave you. Did you see this AAB here? Before you're only working with like AAB, but now you're working with before you're working with ABA. Now you're working with AAAB. And this is something that you didn't really test for in your initial design. You kind of just wrote the design based off one example, and then you're trying to modify based on the second example that you give.
Mhm.
So basically, this is kind of where I think the one of the big issues that you have is that you don't really set yourself up to write code correctly from a design perspective. You don't really have good tests. That's basically what it boils down to.
Mhm.
And so, one of the things I really try to tell people is that if you come up with good tests and you run through the tests with your design, it kills two birds with one stone. The first one, it bulletproofs your design. The second one, it tells the interviewer exactly what you're doing.
Mhm.
And for you, I think this is actually works pretty well because, I mean, you definitely got the right answer, sure. But what I found weird is that your design and explanation was very off, and that you didn't have the test cases to begin with. And to me, that's like it's okay for an intern probably, but if you were like an actual employee, I would be like, whoa, what are we doing with this guy? But I think it's still very good for you to at least um, do the tests first. At least show that you're capable of setting yourself up to write good code, because that's like what nine out of 10 times that's usually what the problem is. It's like there's
Mhm.
just some consideration or some edge case that you didn't really consider. Um, okay, so moving on. Um, I had to tell you that around 9 minutes. Like, okay, you're starting to change your design, but you didn't reflect that back in your pseudocode. Do you
Yeah.
remember
Okay.
this? Yeah. So I
Mhm.
would try. I would definitely. This is why I always say try to English sentences because you can. It's so much easier to understand what you're doing. Whereas this
Mhm.
is like code. So to me, to in your mind, it's just like, oh, it's just technical stuff. I'll deal with it later. But then I would argue that if you do that, then you might end up losing the interviewer and yourself because you're just talking about these ideas and you have so many ideas through your head. But if you don't write them down, how do you remember them? How do you know how they work in the
Yeah.
bigger picture? And especially since you're walking through the example, right? So you should at least have a template to go back to that says exactly what you're doing with each example.
Mhm.
So this is something I think you need to get used to. I remember saying that before. It looks like you're forcing yourself to do it rather than
Yeah.
um, you have a natural inclination for it. So go if you decide to practice more before your snap interview. I would recommend writing these problems in plain English, your design step. It's like it doesn't take long to do this. Like do this for like 10, 15 problems, see how it feels. And if you decide you don't like it, don't do it. But I think you might find that it's a little bit easier to play with.
I think it will be as well.
Yeah. It's like if you like, I don't encourage people to do something they're not comfortable with. If this is how you do it in practice, do it in the interview, even if it's wrong. It's better
No,
to do
it seems a lot more reasonable to just write in plain English. It's a lot more easy to like modify, and yeah, I
Yeah.
see what you're getting at.
So then you kind of rush through your design here. I think it's like you have an idea in your head, fine. But then it's like I remember for like some time I was trying to figure out like, oh, there's a bug that's only because I misunderstood the problem. But the thing is that that's still a misunderstanding.
Mm-hmm.
So it's like if you explain that this last character was the last character that you added to the new string, but then again that is kind of reflected in last character. But then the naming convention also says, hey, wait a minute, why don't you just use the new string? So maybe you should say last character frequency tuple or something. So it's a small thing, but it actually ended up making like kind of big difference here because last character implies that it's just a character.
Mm-hmm.
Even though the variable name and the assignment doesn't really lend itself to that. So it's small things, but it can throw off the interviewer. In case it kind of threw me off too, because I'm not a Python I mean, in a normal interview, have a Python programmer who would be used to this. So that may not necessarily be an issue, but in this particular case, it was because I'm a Java programmer. I don't deal with this. So that could be me, but take it for what it was. Again, 14 test cases. Okay, that's fine. And then it ends up burning like about I think 3. Yeah. So this misunderstanding ended up costing a lot of times. Like you're redoing it, you're trying to see your problems, but then even then, your test cases aren't bulletproof. So it's not like you're convincing me of the correctness of your solution. Like in one of the videos, I don't know if I mentioned this before, but the idea with your test cases is to be able to handle any and all situations that you can reasonably come into. And the way you describe how you generate test cases is like, oh, what other strings can I throw at it? So you come up with like A, A, B, C, C, D. What is this supposed to represent?
Yeah, honestly, I had like no idea what to do. I definitely need some tips or like some like framework to build full like a broader coverage of test cases with.
So if you saw my video on how I solve problems with that tree example, I basically listed out all the possible scenarios this situation could come into. And I briefly showed you that these are like your dependencies before you enter the loop. So what are the possible combinations that you can have for these dependencies? And then from there, you can derive a example of when you'll run into that.
Okay.
So it's just basically about that. It's what are the cases that your code would run into, and then what's an example of that? Because you would agree that me providing AAD is no different from providing AAB, correct?
Yes.
Because these are two distinct characters, but you have 3 characters running around with one of them being 2 copies.
Mm-hmm.
At the core of it, in the context of your logic, these two AAB and AAD are exactly the same. So that's kind of the philosophy I go with when coming up with test cases. So I'd suggest you do that as well, although it's kind of hard to make that change because it kind of requires you to have a sense of what constitutes a good test versus a bad test, and that takes a while to learn. And I don't think you have time to do that. But it's just like if you have that insight and you want to try it out, just go for it. Again, like we're pretty late into the game, so it's not like I want to really give you something that will throw you off. So, 20 minutes, yeah. So we started at around like 12, 13 minutes, and then we burned like 7 minutes just trying to because of this misunderstanding. So, yeah. I'm trying to go through the test case. Oh yeah, like 10 minutes. Wow. Yeah. So then that misunderstanding kind of did cost some time. Like it's nothing to do with like your ability to solve the problem. It's your ability to like really just guide me through these design changes.
And yeah, communicate, I guess.
Clearly. It should be like you shouldn't over communicate it. You should communicate better.
Okay.
So like you have a design here for a reason. So if you had done that, if you had like focused a little bit more on being able to make this like plain English and help someone understand with this, I think you would have been better instead of like trying to overtalk it. Because
Okay.
I definitely get that sense that you tend to talk and communicate about the wrong things. Do you find yourself doing that?
The wrong things.
Like you focus on the things that are not important.
Yeah, I guess I over elaborate on like kind of unimportant topics.
Hmm. Like I don't really care about that.
Hmm.
Like, it's like we're trying to still solve the core issue of like, what's the problem we're dealing with at the current moment. The current problem is that I think there's a bug, and then you try to like go through the code, but then the core of the misunderstanding is that there's no test case that convinces me of like of what you're doing. So
Hmm.
that's not communicating with words. That's communicating with your code and the way you've designed the your solution. Does that make sense?
Yeah.
You're designed to do the talking, most of the talking, and you're only there to fill in whatever can't be reflected on with design. That's it.
Hmm.
Because like words travel through one ear, get processed for a brief second, go out the other.
Yeah.
Because I'm not going to spend like a super long time just trying to understand English, the English that's coming out from your mouth. Not
Hmm.
no disrespect, but it's just like I'm here for the code. I'm here for the problem. I'm here for the solution on the board. Whatever you say is like in service of that. So whatever you've written down here, the whatever is related to the problem, is what I'm judging you on.
Hmm.
So
I see.
that's fine here. And then this last bug, I think the coding here is okay. I think you can get away with not really talking as much as you did. Like you say, oh, this is a tuple, this is a dot, this is that. I don't think you necessarily need it. I think
Super
this is
pros.
yeah, too verbose about the wrong things. I think the fact that you mentioned this heat push thing about Python is fine. Like the way the frequency is balanced, I'm okay with that.
Hmm.
But the rest of the stuff, I think rest of it you didn't need to talk it out, especially because you put this like frequency -1 versus frequency times -1 here. Sorry, no. I
Yeah.
mean like this frequency -1 here, and
Okay.
then this frequency
Hmm.
-1 here. That's the bug, and I was surprised you didn't give it a chance to really think it through. So really, you could have turned if you cleared up your design step, you could have turned this problem from a 33-minute problem or 37-minute problem into like essentially a 25-minute problem or less.
Hmm.
Misunderstandings notwithstanding, but even if like you have to do some talking, you could turn it into 25 minutes and kill this problem easily, and then move on to the next one.
Yeah. Okay.
But even then, like this bug is not excusable at all.
Hmm. Overlook that.
Like if you again, like you should be looking back at your design, like and say, oh well, where do I execute the frequency minus? You say you push back the last character, so you should avoid combining operations. Either way, it's just that yeah, just focus on that. I would just focus on
Hmm.
the design a little bit more and try to dumb down the language for a 5-year-old.
Yeah. Okay. Yeah. That makes a lot of sense. Thank you.
For sure. You have any questions for me?
I do. So I'm currently, well, like I did most of my studying over the summer where I was like able to do it full time. Now, like I'm a full time student. So, do you have like any tips for people who, like can't dedicate their whole entire day to studying? I guess.
I mean, it's 3 4 hours a day is plenty actually. For me, I did that because like after work, I had a full time job. Went to the gym. After gym, 8 9 p.m. 9 p.m. to midnight study. That's what I did. And then
Mhm.
on the weekend, Saturday, Sunday, I basically spent 10 hours studying. So I mean, you can extend out that to about like 2 3 months. I mean, I did mine in 6. I did my study in 6 weeks. So I think for a student, 2 3 months is plenty of time. Especially because they're not going to be as vigorous or as demanding from you there in terms of your rigor on these problems.
Mhm.
But at the same time, I wouldn't slack. So basically, I don't think anything should really change. Just spread out your time and give yourself more buffer room.
I see. Okay. Sweet. Thank you. Um, hmm. I guess like one like burning question is like bottom line. Would this be like a pass or a no pass?
I would not pass you honestly. The bug was not really that great. Look,
Hmm.
and the fact that you gave up on it so easily was not great either.
Yeah. I don't know.
Um, yeah, that was really bad. I would have at least even if you didn't do well in design, that's fine because a student. I would have probably given you okay on that. The fact that you had thrashed around, it's like eyebrow, but not bad. I would have, and for even for a full time or new grad, I would be leaning towards no. For intern, I would be okay with like okay, I get it. It's a student who doesn't really understand the nuances of engineering, but at least he's making progress.
Hmm.
But yeah, but coming down to it, finding this like small bug and the fact that you gave up on it was basically a deal killer for me.
I just didn't spend any time looking through that, did I?
Yeah, yeah, that
And that
was
was
bad.
like that was like a mistake that just came from moving out of that initial design. So really need to focus on design, getting it more readable for myself and the interview, I guess.
It's more like it's definitely a good way of slowing down the interviewer, especially if you find yourself rushing or talking too much about things, because you'll be focused more on trying to make sure that interviewer understands in plain English what you want to do, and then the rest is just implementation. At which point, it's like anyone can write code, in my opinion, but it takes a very special mind to really translate that to a human readable language. Because when you get to the actual workplace, you're going to be working with people who don't have the same technical knowledge as you. They might not understand their tech stack, like if you're their programmer on another team, or there might be products who are working mostly on drawings and design and assets, and they might need to understand what exactly your code or algorithm is supposed to do. So you need to be able to translate that into plain English. So
Hmm.
it's just doing that in reverse.
Yeah, I see. Okay. Well, yeah, thanks again for your time.
Mm-hmm.
Really
Sure.
appreciate it.
Yeah, for sure, man.
Um, Anything else, or is that it?
I would say yeah. If it's like you have basically 10 days until your interview. Don't do anything too drastic. If it, just spend a day or two trying what I suggested. If it works out for you and you find that you're doing your problems faster and better, great. If it doesn't, don't harp on it. Don't push yourself to force yourself to adapt it. Just focus on fixing these small little mistakes for now. If you had like 2 3 weeks, I would have said something different and told you to actually give it a solid weekend to try. But
Hmm.
just try it out, see how it works. If it doesn't work, it doesn't work.
All right. Well, sweet. Thank you again.
For sure.
Really appreciate it.
But take care, man.